This is part 2 of the Nanobot build and mainly covers the radio setup, flight controller wiring and the maiden flight. If you haven't already done so, I suggest you watch part 1 to see how this frame is actually put together. Let's get on with the build. So before we go ahead and do any flashing of firmware on our flight controller board or any sort of setup, we're going to create a new model on our radio, which is the obligatory Taranis. First thing to do is to scroll down and create a new model. Create model. And we're going to be using a quadcopter. My radio is set up for mode 2, so all I have to do is to page through the various channel assignments to the controls. And this is basically saying throttle is on channel 3, roll is on channel 1, pitch is on channel 2, up and down this way, and yaw is on channel 4 that way. And we just have a long press to confirm that's okay. Model's all set up. So, it's called Model 6. Go to page 2, hit enter, and we just use these buttons to scroll through and give it a name. I'll just call it Nano for now. If you skipped over that, if I press enter and hold it, it changes it to capital. The first thing we're going to do is to allocate the switches that we're going to use. This is completely down to personal preference, and I stick to the same switches between models so that I know where everything is and I don't get confused. I tend to use switch SC for arming. I used switch SE for the different flight modes, and I always have this set to angle, horizon, acro. But let's get the arm switch and the flight mode set up first, because they're the things that are crucial to actually getting the flight controller programmed in Betaflight. Hit page. We go back to menu, sorry, hit page and run through here until we get to inputs. This is page 4. And all we're going to simply do is add the arm switch and the flight mode switch. So I'll do the arm switch first. So we hit enter. We're going to give this input a name. So it's just saying the input is coming from this switch. And because it's the arm switch, I'm just going to call it guess what. Exit out of that. Scroll down to the source. This is basically saying this is the switch that we're going to be using. If we hit enter, we could scroll through, but actually all you need to do is flick the switch, and you can see it's gone to SC, and that is switch SC. Hit escape, takes us out of there. Escape again, takes us back to the menu, and we can see that we've got a new input here called ARM, which is on switch SC. Next thing we're going to do is go to the next free input, which is 6. Hit enter, hit enter again, and we're going to set up switch SE as the flight mode switch. Done that too quickly. Hit enter, and we'll call this mode. Scroll down to the source, hit enter to select it, and then all we're doing is flick the switch a couple of times, and you can see that says SE now. Escape, takes you out of edit, escape again, and it takes you back to the list of inputs which you've got. And as you can see, we've got here our standard aileron, elevator, throttle and rudder, and these are the two we've added. Now this doesn't actually, I've been asked this a number of times, there is another step you have to go through. That's just selecting the switches and what the inputs are. You need to map those to how they are going to be output from the radio, and you do this by going to the mixer page. By just hitting page, it takes you to the next page. If you don't do this step, you will get no output from the radio. So we go down to our first free one, which is channel 5, hit enter. We'll call the mix name ARM, select enter to start editing a long press. Escape out of that. Now you can see it's actually already selected the source. The source was ARM, the ARM input, which we'd mapped to this switch. So this is ready to go. If it wasn't selected, you could hit enter and you could flick through. You can see it's selecting all the inputs that were on the input screen. But we actually want that to be the ARM input. Hit escape, escape again, and you can see now that in our mixer settings we've got the input ARM, which is going to the output called ARM here. So the ARM switch is ready to go. Scroll down to our next free slot, which is channel 6, hit enter. The mix name we're going to call mode, hit enter, and you can see that mode has already been selected as the input. That's what I quite like about Taranis, is a lot of the things you want to do quickly, they're already set up for you. So we've got this mix name on channel 6 called mode, and the source is the input that's signified by the I there called mode. We can exit out of that now. So radio is ready to go. Okay, one last important thing that we need to do before we connect this up to the computer and flash Betaflight on here is to bind the receiver to the radio. It's very straightforward. In the top right hand corner here there are 2 solder connections. They've already been tinned. You need to short those out. That's basically to put the receiver into binding mode. Very straightforward. Do this. There we go. So basically there's a small blob of solder sitting across those. Once we finish the binding process, we'll just pull that solder off and we'll be ready to go. So let's turn our radio on.
Welcome to OpenTX.
Okay, so the model that is selected is the one that we just added, and we haven't set any failsafe for that yet. This is why we're getting that warning. So we'll just quickly do that now. Hit page, go to menu. Nano is the one we've got selected. Hit page to take us into page 2, and if we scroll up here using the plus key, you'll see that failsafe is not set. The way most people set these up, same as me, is that if you don't get any signal, if this doesn't get any signal from the radio, it just shuts down. Basically stops the props and it will drop where it was just last flying. It's a requirement for racing as well. So hit enter. Don't want hold, don't want custom. No pulses is the setting that you need. Exit. It's all good. And if we turn the radio off, because the radio remembers the last model that was selected,
welcome to OpenTX.
We don't get that warning any longer. So we're ready to start binding now. We need the battery. We've got our receiver with the 2 pins bridged out with a piece of solder. We'll turn our radio on.
Welcome to OpenTX.
We don't get the warning any longer that failsafe hasn't been set. Hit menu and hit page to take us to page 2. We want to scroll up on page 2 to this section. Now the mode this needs to be in is actually D8. Hit enter. There we go, D8. Never sure which way it is, but hit plus. So escape out of that. And we've got channels 1 to 8, that's great. We are going to select bind, hit enter to put it into bind mode, and you hear the bind beep. connect your battery to your flight controller, just double checking that red is red and black is black. Sometimes I found these Turnigy cells, they're wired a different way round on the micro lossy connector. Just double check. You don't want to fry it. So don't get too close to the radio. We can put it up like that. So that is now bound. We unplug the receiver. We can exit out of that now, which is good. Let's just unbridge this solder joint. Just swipe the solder away. That all looks good to me. So we're bound, everything's set up. A quick way to check whether your receiver is actually bound to the radio is take a charged battery, plug it in, and you will see the red LED just indicates there's power on the board. This blue flashing LED here tells us that it's not actually receiving any transmitter signals because it's flashing. If we turn the radio on,
Welcome to OpenTX.
there we go. This blue LED has stopped flashing, it's gone solid because it was bound to the model that we've just set. So we know that's all working fine. Turn the radio off and it started flashing again. So that gives us confidence that we are now correctly bound between the receiver on this board and the model that you have set up in the radio. Okay, let's get on and flash some firmware. So we've got our flight controller board wired up with a micro lossy connector, and we now need to flash Betaflight on here. As standard, these come with clean flight, but I found actually that these smaller quads do work significantly better with Betaflight. So all we need to do is connect the board to our computer with a USB connector. It's all good. As I say, no batteries required for this because it powers itself off the USB connector. I'm doing this on a Mac, but CleanFlight and Betaflight are both Chrome apps, so it's agnostic as to the OS. I actually find with Mac it's much easier because there's less work involved in having to install any USB drivers. So let's have a look and check and see what we've got. The CleanFlight Chrome app is easiest to find just by searching for CleanFlight Chrome, which you can get from the App Store, the Chrome Web Store. As you can see, I've already got this installed, so we don't need to do anything. At the same time, we can just check that Betaflight Chrome app is installed on here as well. Again, you can find that in the Chrome Web Store. As we can see, Betaflight's here. I've already got it installed. So let's have a look. First of all, we'll go to the app launcher. As you can see, CleanFlight and Betaflight are installed. Let's go and have a look at CleanFlight. We hit connect to connect to the controller. If we waggle this around, we can see that it's actually responding correctly on the screen. If you go to the CLI, the command line interface, and enter version, we can see here that this is actually already flashed with CleanFlight, the SP Racing F3 Evo version 1.14.2. This is the one that's specifically for brushed motors. So let's disconnect from that and we can close clean flight. So let's have another look with Betaflight. Betaflight's up and running. If we try and connect to it, we're going to get these warnings simply telling us that we're using Betaflight on our Chrome app, but Betaflight isn't actually flashed onto the board. So flashing this is a very straightforward process. It used to be much harder than this, it's much easier now. So if we disconnect and go to the firmware flasher, it's already picked up the fact that this is an SP Racing V3 Evo board, and we'll select the latest version, which is 2.0.1, and load the firmware. That's simply downloading it from a server somewhere, and we can start flashing this. So these settings are all good. Just hit flash firmware. There we go. Excellent, that's all done. Go back to the welcome screen, hit connect, and I'm now connected correctly to this board, and we can see it's responding to the accelerometer movements on the flight controller board. Go to the command line interface, type in version to find out what version we're running, and lo and behold, now we have got Betaflight SP Racing F3 Evo 3.0.1 flashed onto this board. So we can now start going through and setting this up. So again, we connect. Won't worry about calibrating the accelerometer. First thing to do is set up the ports. We're going to be using UART2 because this is SBUS. So the first thing to do, most of these settings that you'll find in here you don't have to do very much to. So we're going to UART2 and we're going to turn that on for serial RX. Anytime you make a change on any of these pages, don't forget to hit save and reboot, just to actually upload that data back to the flight controller. Configuration. This is up here where we set what type of ESC protocol we're going to be using. The great thing about excuse me, the great thing about Betaflight is that it understands whether you want brushed or brushless motors. This was something you used to have to set up in the CLI previously. We're going to set the PWM motor speed separated from the PID speed, and you just set this value to 3200. This just stops the motor spinning up as soon as you connect the power to the flight controller. Don't spin the motors when armed is my favourite way of doing things. All these settings can stay as they are for the moment. We may tweak these later on. These are standard settings for a Taranis. We scroll down here. That's what I was looking for. It's change position. What type of receiver we're using? We're using serial based, and it's SBUS. So just select that. And select SBUS in there, and I think that is pretty much it. None of these have any bearing because they're not actually features of this particular board, so we'll hit save and reboot. That's great. PID tuning, we'll leave those till a little bit later. Receiver. So our receiver is already bound to the transmitter. I'll get the transmitter over here and turn it on.
Welcome to OpenTX.
We've got Nano selected. And the first thing to check is that you've got the correct movements on the transmitter and they are matching up to what you've got in here. It depends how it's mapped using this value, but for the way that I've got this configured for the defaults, this is all fairly standard. So roll, full left, full right, pitch, full forward, full back, yaw, full left, full right, throttle, all the way up, all the way down. Switches, remember we selected SC as our arm switch, which we'll connect up in a second. We've got the SE switch, which is a 3-position switch there. Those are the main settings. We may actually configure the SH momentary switch up as a lost model alarm or a timer reset. Not too sure yet. We'll decide how we can do that in a second. But we know that that's all working, which is great. So that's all we need to do at this stage for a minimum setup on the board. We can hit save and we can disconnect. So we've got our transmitter set up, we've got it bound to our receiver, we've got Betaflight set up to actually take advantage of that, and we know that that's all working. So all we need to do now is start wiring this up and connecting it up to the quad itself. We're almost ready to go. It's now just a case of soldering the motors onto the flight controller board. This can be a little bit fiddly. I like to do it by connecting one side first off the board and then sticking this to the board and connecting the other wires across. You've also got to decide where you're going to put this short antenna. I tend to just fold it back over the board when it's finished, which is fine, there's plenty of room there. And we also have to connect a small buzzer and I'll just solder that directly onto the board here with the pins. There's plenty of room. That can just be held on by the solder onto the PCB, and it's protected underneath the top plate, and there's plenty of room there. Fixing the board down on this particular board, there are some surface mount ICs underneath. To make this level on the board there, I like to use a couple of strips of foam just to bring it up to the same height. It's not necessarily going to stick too well on here, but it's really just to make sure that the flight controller board stays fairly level, which is important. So we can just stick that on there. I found that one piece isn't actually quite enough, so we just stick that on there. I'm not going to peel this section off for the minute, and that keeps that nice and flat, stops it moving about. It'll be held in place primarily with the elastic band across the top. So let's get these wires soldered up. Just take your time. The way these motor connections go, which we've already pre-tinned, is motors, it goes motor 1, 2, 3 and 4, and the positives are all at the bottom. I think first of all I'll actually connect the buzzer, and that works with the positive at the bottom and the negative at the top. So there we go, that's all wired up. We just need to attach the camera. is the Eachine TX03, which I haven't actually tried yet, but it does look pretty good. So this is going to mount just there, like that, and the wire is coming out in a slightly different place. It's coming down here, so I'm going to make a little cutout. The beauty of these TPU mounts is you can just modify them to whatever you want. So we just need to make a small cutout to accommodate the wire just down there. Just cut that out with a blade. There we go. It needs just a little bit more, maybe. No, that's good. That's perfect. Initially I suggest you set this up with the camera completely horizontal. You might want to put a bit of packing in to bring it back this way as you start to fly quicker, but you probably won't need it. We'll just fix this down with a small piece of double-sided foam. Like I say, if you want to, you can actually attach this with an elastic band around the top if you find it doesn't fit. But the whole point of this TPU mount is it accommodates all of the all-in-one camera transmitter models that I've tried. Well, certainly the more recent ones anyway. It's always so fiddly. There we go. That just pushes down into that, which is great. And if you're using one of the cameras that comes with its own case, I suggest you just pull it out of the case, and this is what it'll look like anyway. We can get to the channel select button at the top. This one, as well as having different bands and different frequencies, the power output is selectable as well. Okay, so I haven't attached the buzzer yet. I'll do that in a second. So let's quickly remove the film off the back of this double-sided sticky on the back here, because we're almost ready to just tie this all up now. If I can get that off. It's a bit fiddly in there. This is a bit of a tight build, but as long as you take your time, you'll be fine. There we go. Excellent. So that can now be located down onto the bottom there. That's great. Just be a little bit careful with this antenna wire. Okay, excellent. I'm going to secure this down now with the elastic band. Don't want to put the antenna under there. And there we go, that's just to keep it in place. Excellent. Okay, so everything is now connected up. We can do the final setup of Betaflight now. One thing to do before you connect any power, whether it's USB power or whether it's directly off your battery, have a check round, make sure you've got no solder bridges, there's no stray hairs of wire sticking around. Use a magnifier if you need to. It's best to double check this and do this now rather than waiting to see that you've got a solder bridge across the motor outputs, the ESC outputs, and you blow something up, which is not very pleasant. Okay. So we just need to plug the computer back into the USB port. Again, no batteries needed because it's powered off here. Encouraging, is making the right noises. And we go back into Betaflight and connect to our quad. First thing to do is check that it's working. That's great. Make sure it's nice and flat on the floor. And we can calibrate the accelerometer. That's great. The accelerometer is only of any relevance if you're flying in angle or horizon mode. The accelerometer is turned off when you're flying in acro or rate mode, depending on how you look at it. We need to set up our modes. We've previously set up the switches on the radio so that when we move these around, we're going to use AUX1 and AUX2 for our arming and our mode switch. So let's go into modes. We need to add an arm mode. We're using AUX1. If we move the arm switch backwards and forwards, you can see the marker on the screen moving around, and we need to set that so that when it's in the down position, that arms the quad. There we go. And we hit save. Now we know that everything's working because we're getting a buzzer beep every time that happens. It's not actually firing up the motors because one of the safety features of the flight controller board is when there's no battery, an external supply connected, then it won't fire up the motors, which is good. But we'll check all that in a second. Next thing we need to do is set up angle mode. Basically, this we're going to be using the switch which we set up before, which is AUX2, as we can see on here. AUX2, 3 positions. The way I like to set it up is that the full far away position is AUX, middle position is horizon, and the back position is acro. So let's set up the angle mode first. So pick angle mode, add range. We're going to be using AUX2. If I move the switch backwards and forwards, that is in its back position. So we move the sliders down here to capture that. Hit save. That's great. So it's an angle mode. Arm is working. You can hear it beeping, but you can also see it's monitoring it on here. That's great. Horizon mode. We're going to set that again using AUX2, and that's going to be the middle position of the switch, which is there. Hit save. Excellent. So as we can see, we flick this around, we go between angle and horizon. Now, one of the features of CleanFlight and Betaflight is that when angle and horizon are not selected, then it will actually be in acro mode. So if I pull it all the way forward, we'll see that neither of these two are selected. So that actually means now that the board is in acro mode. I like to use air mode as well, and air mode is only of any real use when you are flying in acro. So the way I like to configure this is again to use AUX 2 and simply set it to trigger air mode when the switch is in the backmost position, which is basically acro. So air mode only comes on when you're in acro mode. So we have angle, horizon, neither angle or horizon selected, so it means that's in acro, and air mode is selected. Perfect. Hit save. That's all done. And if we go back, let's just disconnect that. If we go back to our quad and disconnect the USB connector, make sure all the switches are in the right position, we can take a battery and connect it up. Transmitter's on. Excellent. So that's connected. If I arm it, the motors aren't spinning up because if you remember I set the motors not to spin whilst it's armed. However, you can hear they're all running. This is a good time to check that the motors are running in the right direction. So these two motors should be running clockwise, these are running anti-clockwise. Just spin it up and just feel for which way the spindle is running. That's correct. If you need to, just put a little piece of tape on there. This is great. So we can now disarm and we can undo the battery and we're ready to wrap this up. Before we actually attach the top plate, one last thing I like to do is just make a little rollover cage to protect the VTX antenna. You can do this with a couple of cable ties and a piece of heat shrink. I find the best way to do this is simply cut out two small holes in the vanity plate here with a knife. Two small slots are fine. And then you can feed this cable tie down through the hole like that. Just pull that tight. Same on the other side. That's going to run up around that way, so it needs to go down through there. Just like this, it's very simple. Because otherwise you will damage the antenna. It's only soldered onto the board. It's easily broken. There we go. So there we have those two cable ties like that. All we're going to do is snip these off at the same height. Get a piece of heat shrink, it doesn't need to be too long. and push those together like that to create yourself a little hoop. A bit of trouble here, probably a little bit too long. Cable ties are best for this because they're nice and resilient and they're incredibly strong. So it needs to be about that sort of height. Make it as high as you need to, basically. And you can just shape this into, whilst everything's still warm, get it into a nice shape. There we go. So we have a little protection for our antenna. This can then screw down into the body standoffs. One last thing to do is attach the props. Now this was designed specifically to take up to 65mm props, and I found it performed really well with these Gemfan 65mm ABS props. You could put some Hubsan 55mm props on here as well. They'll spin up a bit quicker. I found the best flight time, the best stability came with these Gemfans. Obviously you can put whatever you like on there, make sure you get these the right way around. So that's clockwise. Now when you're when you're putting the prop on the motor, make sure that you support the bottom, because the last thing you want to do is push that out from the bottom there. You can do that by just gently pushing that down, and make sure that you push it as down as far as it will go without actually binding. That means when you land inverted, if you have those sticking up, you land, it will hit the top of the prop and push the armature out the bottom of the motor. Guaranteed. So there we go, that's all the way down, but still free to turn. Get this one on. Let's give it a quick test with this battery.
Welcome to OpenTX.
Excellent. All looking good. Hold it down just in case. And we can just double check the props are spinning the right direction. These are designed to just clear the camera mount. Make sure there's no wires in the way. So here we are for our first FPV flight. I'd already done a quick line of sight test with this, but I didn't have the DVR connected. And the first thing that struck me was just how fast this was. It took me totally by surprise. It was incredible. A little bit twitchy, so there's obviously some PID tuning needed here. But generally it flies really nicely. Look at that down through there. This almost looks like it's speeded up, but it's not. This is the speed that it flies at. And one thing I'd say is if you're using the Eachine TX03, the temptation is to select the power output to be 200 milliwatts because you think you're going to get the best video range, and you will, but it drains the battery so quickly because it's using so much power. I find 25 milliwatts, the lowest setting, is actually more than adequate for flying around in these sort of situations, and it works really well even in big fields. The only time you might get a problem is if you're flying through buildings or behind big leafy wet trees. But yeah, it's starting to get a hang of this. It really is awesome fun. These are the settings that I find work best with Betaflight 3.1.5 on this quad. As always, if you've got any suggestions or improvements, please let me know. Well, there we go. I hope you found that interesting. I've certainly had a great time designing and building this little nano quad. As usual, if you've got any questions, leave them in the comments section below and I'll do my very best to try and answer them. And we'll see you next time.